This is lesson 1.5, day 2. Today we're going to talk about rational and irrational numbers. So let's start with this picture. Here we have the real numbers. The real numbers are the number system that we use in our math class. And later on in your math career you may encounter different kinds of numbers, but this is what we are limited to in 8th grade. Alright, so the real numbers are divided into two categories. We have the rational numbers on the left and then the irrational numbers on the right. Notice that the irrational numbers are a category all by themselves, but the rational numbers also have subcategories, which include the integers, the whole numbers, and the natural numbers. So look at those sets. Starting with the natural numbers, you can see that starts with the number 1 and continues on increasing by 1 in the positive direction. So 1, 2, 3, and the dot, dot, dot means that this keeps going and going and going forever. The whole numbers include the natural numbers, except there's one more number included, and that's the number 0, right? Because 0 has a hole in it, so it should belong to the whole numbers. And you can see that they start with 0 and also continue in the positive direction forever. Now the integers include the whole numbers, 0, 1, 2, etc., 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 and their opposites. So the integers include -1, -2, -3, etc., etc., all the way in the negative direction. All right, so those are our real number categories. Now let's talk about the rational numbers. The rational numbers, think about that word rational, right? That word rational means like you think about it, right? Like if something is rational, that means it's sane, it makes sense. Okay, so here we have our little monkey friend, right? You know, he's in deep thought there. He's a rational monkey. And he's making sense of things. And so rational numbers are those numbers that can be written as a fraction using integers. So let's do an example of that, a fraction using integers. So 1 over 2. 1 and 2 are integers, so it's a fraction that is considered a rational number. All right, how about -3 over 4? All right, well, -3 is an integer, and so is 4, so that meets our definition. -3/4 is a rational number. How about this? Square root of 2 over 5. Now, square root of 2 is not an integer, right? Because that's underneath the square root symbol. And so this is not considered a rational number. That wouldn't fit our definition. All right. Now our other definition of a rational number is that it's either a terminating or repeating decimal. All right. So if it can be written as a fraction using integers, then it can be written as a terminating or repeating decimal. So 1/2 as a decimal is 0.5. Right? Divide 2 into 1, you get 0.5. That's an example of a terminating decimal. It ends. Okay? Now remember repeating decimals. Repeating decimals keep going and going. And so, for instance, 0.6 repeating. Okay? That would be considered a rational number. And we could write that as a fraction using integers. Okay? And we did do that. If we were to change 0.6 repeating into a fraction, the fraction would be 2/3. All right? So if a number can be written as a fraction using integers, then it will also be a terminating or repeating decimal. We call those numbers rational numbers. Now let's talk about the irrational numbers. Okay? When you think about that word irrational, if someone's acting very irrational, that means they're not acting very sane. That means, it's crazy, berserk. Irrational numbers are like crazy numbers, okay? They don't really make a lot of sense sometimes, because we can't write them as a fraction using integers, all right? If you have an irrational number, there's no way you can write it as a fraction with just integers in the numerator and denominator. You won't be able to do that. You'll end up with something like we had before, like a square root of 2 over 5, okay? That is a fraction, but it's not using integers, so it's irrational number. Okay, if I tried to take my irrational number and write it as a decimal, guess what? it would not terminate, and it would never repeat. Okay, think about that. Decimal that keeps going and going and going without ever stopping, yet it never repeats. So a good example of that is the number pi. The number pi is like 3.1415926, blah, 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 blah. It keeps going and going and going. It never terminates, it never has a zero remainder, and it never repeats itself. So it just keeps going and going. It's totally an insane number. All right, let's classify these numbers as rational or irrational. And I would encourage you to maybe pause your video, go back and look at your notes, and then you can restart the video to see how you did. All right, the first example, 0.3 repeating. That is going to be a rational number. Okay? It's a rational number because it has a repeating decimal. And if it's a rational number, that means we can write it as a fraction. And 0.3 repeating, we could write that as 1/3. Number 2, negative 5.4. This is a terminating decimal. So this would also be considered a rational number. And I could write this as a fraction if I wanted to. This would be negative 5, and then 0.4 means 4/10. And then I can write this as an improper fraction. It would be negative 54/10. Number 3, square root of 49. Well, the square root of 49, the positive root is 7, which is the same as 7 over 1 or 7.0. So it's a fraction. It's also a terminating decimal. This is a rational number. Finally, number 4. Now, number 4 is a square root of a number that's not a perfect square. Now, square root of 10 is not 5 because we're not dividing by 2. We're looking for the number that multiplies by itself to make 10. Well, we know that 3 squared equals 9, so the square root of 9 is exactly 3, and that 4 squared is 16, so the square root of 16 is 4. So square root of 10 is going to be between the numbers 3 and 4. And if you take your calculator and hit the square root button, you put 10 square root, you get 3.1622776, blah, 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 blah. It keeps going and going. So this is an irrational number. Okay, it's going to be one of those crazy, insane numbers that never terminates and never repeats. All right, try these. You may pause your video and then restart to see how you did. Welcome back from pausing the video. So we have number 1, square root of 4 over square root of 9. Well, square root of 4 is equal to 2. Square root of 9 is equal to 3. That is a fraction using integers, so this is a rational number. Number 2, this is a fraction, and 5 and 7 are both integers. This is also a rational number, which means that as a decimal, it would either terminate or repeat. If I took my calculator and went 5 divided by 7, I would get a number that would repeat. Now, it would be hard to see in your calculator because calculators only go out a few places, but as a decimal, this would repeat itself. Believe it or not, all 6 of those digits are going to repeat. All right, number 3, square root of 2. Well, square root of 2 is between the square root of 1, which is 1, and the square root of 4, which is 2. So this is going to be between 1 and 2, and square root of 2 is going to be a non-terminating, non-repeating decimal. So this is going to be irrational. And then finally, pi, this is an example I gave earlier of an irrational number. It's non-terminating, non-repeating decimal. When you use 3.14 for pi, you're using an approximate value. You're not using the exact value because it's impossible to actually get the exact value of an irrational number because they're crazy and insane. Thank you for listening, and we'll see you tomorrow. And also, don't forget, read some books.